What's up everyone? This is Teacher John, and today's lesson we will be discussing about representation of rational functions. Before we start the lesson proper, let's start with a description of what is a rational function. So, a rational functions of the form f of x is equal to p of x over q of x, where p of x and q of x are polynomial function and q of x is not zero function. For example, q of x is not congruent to 0, then the domain of f of x is all values of x, where q of x is not equal to 0. So we have an example of this particular problem. Example number 1. Represent the speed of a runner as a function of the time it takes 100 meters in the track. Alright, so let's proceed to our solution. Now, since the speed of a runner depends on the time it takes the runner to run 100 meters, we can represent speed as a function of time. Now, let x represent the time it takes the runner to run 100 meters, then the speed can be represented as a function s of x. Now, you can use any letters if you want as a representation for the speed, but here we've used s of x. So, we have this s of x equal to 100 over x as our answer to this problem. Now, observe that it is similar in structure to the formula s equal to d over t, and I know you are very familiar with this because we are trying to relate this one, or we can relate this one as speed, distance, and time. Alright? So this is how to represent the speed of a runner. Again, we're just answering here the representation of a rational function. Now let's proceed to our second example. Alright, so let's continue our example number 2. And take note, our example number 1, we have a representation of the speed of the runner, s of x equal to 100 over x. Now let's continue example number 2. Continuing the scenario above, construct a table of values for the speed of the runner against different run time. Alright? Solution. A table of values can help us determine the behavior of a function as a variable x changes. So let x be the runtime and s of x be the speed of the runner in meters per second. Now, where s of x is equal to 100 over x, we got that one from example number 1. The table of values from the runtimes from 10 seconds to 20 seconds is as follows. Now, we start with 10 seconds because as far as we know, the current world record as of October 2015 for the 100 meter dash is 9.58 seconds, set by the Jamaican Usain Bolt in 2009. So that's why we start with 10 seconds. Okay? Now what we're going to do here, we have x's 10 to 20. We're going to substitute that one in x, so 100 divide x, it will become 10, 100 divide 12, it will become 8.33, so on up until here in 20. Now, we have x, as we know, these are the time, 10 seconds to 20 seconds, and s of x is the speed, meters per second. So this is, for 10 seconds, 10 meters. For 12 seconds, that's 8.33 meters. 14 seconds, that's 7.14 meters per second, up until here. Now, from the table, we can observe that the speed decreases with time, so we can use a graph to determine the points of the function follow a smooth curve or a straight line. So we can use a graph to identify if this would be a smooth curve or a straight line. Now let's proceed to example number 3. So example number 3, plot the points on the table of values on a Cartesian plane and determine if the points on the function s of x equal to 100 over x follow a smooth curve or a straight line. Now, as we remember, in example number 1, we have this function, s of x equal to 100 over x as a representation for the speed. And for example number 2, we have a table of values. Here, for 10 seconds, that would be 10 meters per second. So this is the table of these are the values. Okay? So, example number 3, we're going to plot the points. So we need to write a Cartesian plane, then plot the points. Alright, so we have our sketch here, our graph, and these are the points. Okay, as we can look, this is for 10. Okay, so this would be the x here. This is the x. Okay, and this is the f of x. No, s of x. Okay, x, s of x. Now, for 10, that's 10. 12, that's 8.33. So, as we can see, we already plot the points. What we need to do right now is to connect, to create a line or a smooth curve. What can you see? What do you think? Is it a straight line or a curve? So let's try to connect. Oh, so meaning it's not a straight line, it's a smooth curve. So if we're going to alright. So that would definitely our sketch of this particular problem. Now, for 100 meter dash scenario, we have constructed a function of speed against time and represented our function with a table of values and a graph. So that's it, and I hope you learned something for today's lesson. And see you next time.